Okay, we'll finish with objectives 5.1 and 5.2 here. Licensing is another one, and what this image is supposed to show is we have the base and then base and data, whatever we do. The newer version, in the old version of Cisco, we had this. We would buy an iOS that had the base, and we would buy one that had voice perhaps, and then security, and then maybe data and security. In the new version, the new way of licensing, Cisco's gone much the way of Microsoft, that everything's in the file that we get, and we get to use whatever we license. So this is the older way. We had the base here, and we had the base plus data, so you would have to install a new iOS. You would have to copy the new iOS every time you wanted to change anything. In this case, we just change the license, and then we get that particular element. So newer version begun using an iOS packaging method with a universal image with all the feature sets. Include the IP base, voice, security, and then the advanced setup. We produce one image with all those features for each router series. The software download section of Cisco.com checks the user's credentials, and you've got to unlock the feature set using a software activation process. I've got a little chart here in just a second. Hopefully it'll help make some sense out of that. Defined by Cisco to use the feature sets embedded in the universal image. So what that's saying is we got to go there and get authorized to use it, just like you do if you're installing Windows systems in your network. Manual process: browse to the Cisco product licensing registration portal on the web browser and do some command line commands on your router. And each of the same router model supports software issue has a unique identifying number, or a UDI. It has two main components, the PID and the serial number are what make the UID. So the process here, and this is the kind of new, kind of not new process. The customer purchases the software with a subscription. So at the Cisco licensing portal URL, specify the UDI of the router as displayed in the output, show license UDI. And this is where this is. We had a new pack that generated process activation key here to the customer via the Cisco ID email. Fulfills the pack by going to the Cisco registration portal here, go license, specifies the UDI of the router in the show license, and at the portal type in the pack license that you purchased. The customer types in the pack license here. You purchased or bought from the reseller directly from Cisco. Then we're going to copy or download the license file when prompted. You can either download it at the time, or they'll email it to you. They'll email it to you anyway. Put the file someplace at FTP or TFTP server. From the command line, type the license install URL command to install the license key. So then we're going to install the keys, and then we'll reload the router to apply the changes. The flow over here, we go one, we purchase a package, receive a pack, activation key, obtain a license, a pack and the UDI is required. We go to the Cisco site, and then we get the license file from the Cisco site. Once we get the license file, we install the license on the device. They may expire, they may not expire. Cisco has done a little bit of streamlining with a process called smart licensing, and this is Cisco page, obviously. way to think about like what we're really doing here. Instead of having to install them individually, we're going to have a smart account, the smart account here, and we will, what we do with commerce, purchase the license, and we put the license in the licensing, the smart account, the licensing, bigu.edu, own 10, and they've added some. So hello, and this is the product device East 5 and belongs to Big U, and I'm using one advanced user license, and the device belonging to Big Ed, you are in compliance. So the system, the process uses a smart account central licensing, so that we don't have to do all of that download business that we had before in either of the processes. The really old one where you had to upload the entirely new iOS was sometimes could get to be painful, and I remember one time I tried to upgrade a router, and all of a sudden, golly, the iOS was bigger than the memory on the router. Check it before you do that. One of the first things that the router does is delete the old iOS. So here I got an iOS that I can't install on a router, and then the old one is deleted. Fortunately, we'd made a backup of the old iOS, and we could load it back in, delete what was in Flash, and then reload the new one. The process for the smart licensing is we're going to create a token at Cisco, enable smart licensing on the device, register the device using the token that we created here, and then verify that it is enabled on the device, and then ensure the device is visible in the portal, the account that we created. What it gives us is complete visibility. We can see all of our devices. Time saving because we don't have to constantly upgrade, update, download, upload, keep track of all of the iOSs that we have. Simple configurations, cost effective, easy integration, so that we have the ability to centrally manage. And the little advertisement there is courtesy of Cisco. Logging, again, logs, do we want logs? Absolutely, because we need to know what happened where, and the issue becomes where are we going to save the logs. Console logging, where we see them in the consoles, the default, the router sends all the log messages to the console port, ensures that only the users that are physically connected to the console can view the messages. The next thing is remote terminal logging. It has to be turned on by default. If you're on a terminal, you're not going to see the logs, but it displays the log messages to the router's VTY lines, line VTY 04015, the telnet lines. Not enabled by default, has to be turned on. Buffered logging uses the router's RAM to store the messages. Buffer has a fixed size, ensures that the log doesn't deplete all of the system memory. Achieves this by, it says, deleting the old messages, circular logging. As it gets full, then the oldest log message is deleted and the newer one's put in, called circular logging. Syslog Server, we looked at the Syslog Server a little bit earlier, is not enabled by default, allows the router to use the syslog to forward log messages to an external Syslog servers for storage and analysis. And then we have the SNMP, Simple Network Management Protocol. Trap logging allows the router to use SNMP traps to send log messages to an external SNMP server. Time zone is something that we should have configured here, and the clock time zone command is used to set it. Logging is time stamped with the local time zone. The fetched data local to the data source, and then it's converted to the user's time zone. So what it's saying is if we get something from a different time zone, it's going to convert it to ours, so that when we start doing our analysis, we're going to have everything using the same time. 4 time zones in the Unified Intelligence Center server data source. The time zones that we can configure are the server, the data, the source, report, and the user. So we can have several time zones if they are required. The server time zone defined when you do the installation wizard, not affected, does not affect the reports. Server administrator can view and change the time zone using the CLI command. Show time zone config, set time zone can be used to modify those. The data source time zone is defined when the data source is configured. It's the time zone of the database. The report time zone defined in the report filter. If your call center spans several time zones and you intend to compare reports, run historical reports, use the absolute date range and a specific time period. So time zone can be significant, as well as the time. We did network time protocol NTP earlier. Use the time zone. User time zone is used to set set it on the user profile itself. When a user in New York is asked to review a port that was run by a colleague in the China office, user accesses the user profile page to change the time zone to match the colleagues, and then runs the report using the same absolute date range, so that we know what time it actually happened to make sense to us. We're going to look at changing that just in a second. This is the last slide except for the summary slide on loopback. This probably goes into more detail. Loopback does a couple of different things. Loopback, if you recall, the loopback address 127.0.0.1 was the reserved address reserved for troubleshooting, called the loopback address. We can do a couple of things with loopback with configurations, and these kind of show this here. Transmit and receive, we send something to ourselves, and this is to check the NIC. Is the transmit working and is the receive working? Line loopback transmits the received bit stream as it is, so it just sends a bit stream. And then we can do a payload, generates a frame as it normally does, and only retransmits the data portion, and this is in a T1 and an E1. An E1 is kind of the European version of T1. So in this case, we're sending something to the other end. We're testing the line. And then remote line in-band sends a repeating 5-bit pattern down here, and we're basically doing the same thing. We're testing the CSU and the DSU. We're actually getting information that goes through the cloud, goes through the CSU, DSU, so they're using testing. To create a loopback interface, a virtual interface on a router, we'll do that. It's handy for troubleshooting. There are some advanced networking systems that are going to require us to have loopbacks or work better with loopbacks, use them for router IDs and those sorts of things. Where we are, the best thing, protocols was the word that I couldn't think of. The best part of it is we want to have a lot of IP addresses when we're doing RIP is the only routing protocol that you do right now, but in ICND2 you do IGRP and OSPF. If you want to have a lot of networks, we can create virtual interfaces and virtual networks. I'm going to bring over another simulator, and we'll look at the time zone and then create a loopback address. Okay, our topology that we've used before. What I'll do is go in here and see if I can mess this up, but we want to set the time zone and then the time itself. So if we go in here, we can show clock. This one is really kind of weird because it's got the default. Let's go ahead and set the clock. And this says UTC, which is Universal Time, Zulu time. So we can do clock set, and then we need the hours, and the minutes, and And let's say that it's 17:09:00, and then we need the day, and let's say it's 16 June 2018, and we show clock. Then we have it's 17:09 here. So now to do the time zone, config T, and then we'll do clock time zone, and then what I'm going to do is say I'm going to be in Central Daylight Time, and we are -6, so we're 6 hours behind Zulu time. And after that we could have minutes. We're not going to say any minutes. That's because some countries actually use half hours. If we now show time, show clock, not show time, says it's 11, and that's going to be the local time. So we set the time, and it says it's Central Daylight Time. The time is now in Central Daylight Time once we have the time zone configured. To make a loopback address, we're going to config T, and we'll just type interface LO and loopback, and then whatever number we want to be in. As you can see, we can have a lot of them. So we do loopback 1, protocol, and then IP address 192.168.100.33. for instance. Actually, what a lot of people use is for the numbers, and we can use this one, 10.2.2.2 with a 255.255.255.0 to represent the router number. And then if we, so let's get out of here, and show IP interface brief, we have our loopback address. Is it okay? Yes. Manual up, and you notice that serial up, so we're up, manual up, so we're in good shape. We show interface LO1. It tells us FIFO's first in, first out. Nothing really going on here, no data on it. So we can look at what goes on. We have 0 runts and 0 giants, 0 throttles. We can create this, and again, this is a great way to do a lot of different IP addresses so that you can configure routing protocols. So with that, what we talked about in the 2 parts, device monitoring, Syslog, and we did a little demonstration on Syslog. We talked about backup and restore. We previously had used TFT to back up and restore a configuration file. Discovery protocols, CDP, the Cisco Discovery Protocol, Cisco proprietary, and LLDP, Link Layer Discovery Protocol. Find directly connected Layer 2, link layer, Layer 2 devices. We talked about licensing, logging, time zone, configured time zone, and then we configured the loopback, talked a little bit about loopbacks. So that should do it for objectives 5.1 and 5.2.